Yeah, life is tough. We don't have much virus build up though. Yeah, that's good news.
Why can't they live in the heat though?
Because they have a fat layer.
It's not the heat, it's that they'll go out the windows.
Oh.
Good circulation.
I heard that they couldn't do it with the heat because the layer, like the virus's DNA encapsulated in the fat layer. The heat just brings down the fat layer.
The heat does?
As Lil Yachty says, you can't take the heat, get off the street.
Yeah,
That's
I
right.
need to get off the street. I'm so hot right now.
Who says that?
Lil Yachty.
Little Yachty?
Yeah.
sir.
Lil Yachty comments on Brittany Brittany.
I never heard of Little Yachty.
Have you ever seen
Big Yachty, yeah.
This is a...
Alright. Okay, listen. So, here are, we talked about this yesterday. Carbohydrates can exist as chains. Just chains of atoms linked together. But sometimes, especially in within cells, these chains can form rings, and you can see them come around and kind of form a ring to make glucose. Now, we've got different types of glucose. We've got alpha glucose, which looks like this. So you need to be able to identify these. We're going to do this in a little bit. This is alpha glucose. See how, first of all, that's a CH2OH group. That goes up, and then there's these two OH groups both going down. We call that alpha glucose. That's the normal glucose you find in cells and in your body. But there's another type of glucose. Check this one out. This is called beta glucose. The OH groups, one's going down, that one's going up. They're opposite of one another. We call that beta glucose. Then you have fructose. Fructose is very obviously different. It's a pentagon instead of a hexagon. So look at the difference there. Very pronounced. All of these, by the way, are C6H12O6. They all have the same formula. They're isomers, yeah. And then finally, you have galactose, which it's not really showing on here. But here's how galactose looks. Look at the difference between galactose. See how this OH goes down away from the CH2OH? Galactose has an OH that goes up in the same direction as the CH2OH. Can y'all see that from where you're sitting? Your eyes are better than mine. So, what's that?
How's your eye feeling?
Oh, went to the doctor yesterday. They found an object way up underneath my eyeball and removed it. Every time my eyeball moved, it scratched my eye.
That'd be wicked.
How did they remove it?
She went in there with tweezers and pulled everything out and said, "There's something in there." I was like, "I knew it."
There's an alien.
What's that?
There's an alien.
It was a little, you could barely even see it. It was a little speck of dirt or something. That's all it takes. It's crazy, isn't it? Glad I went. All right, so those are the various types of, we call these monosaccharides. Y'all know what that word means? Have you ever heard that?
One sugar.
Mono means one. Saccharide means sugar, one sugar. So these are single rings. And yeah, you can break it and straighten it out, but it likes to curl up on itself. And this is what your body uses for energy in your mitochondrions. You remember the mitochondrion, the powerhouse of the cell?
I do.
They can just tear these apart. They like it in this form, but they can deal with it in any of these forms. And so then we can link those together to make our disaccharides. And once again, this is a dehydration synthesis reaction, which, where's my other one? Oh, here it is. Here we have two glucose molecules. And you put them together like this. H comes off of one. OH comes off the other. Now you have H2O. And these are linked together. So, these are called disaccharides. I think that's spelled right. Is that spelled right? So, disaccharides, there are just a few major ones you hear about. Glucose plus glucose equals maltose. Glucose plus glucose. Glucose and... Wait, that's not glucose, that's galactose. Glucose plus fructose is sucrose. You ever heard of sucrose before?
Yeah.
That's table sugar. That's the sugar you put on your cereal. If you're like me, you just load it up, baby.
Heck yeah.
Just load it up. Teaspoonful after teaspoonful. And you eat it, and at the end, after about 4 bowls, there's a pile of sugar on the bottom. It's about yay high. And you can just scoop that thing and eat that straight.
It has a milk in it?
Oh,
Yeah.
fantastic. So that's sucrose. And then the other common one is glucose plus galactose. And that equals lactose. Lactose is a disaccharide. That's milk sugar. And we talk about lactose a lot when we're doing the operon system. The lac operon has to do with lactose. We're going to get to the operon system, how genes are turned on and off, and we'll study the lac operon. So it's for breaking down lactose. So you all have had milk. It's kind of sweet. There's a sugar in there called lactose. Some people are lactose intolerant, which means if they drink milk, they can't digest that sugar. They don't have the enzyme that'll break that bond. They have the enzyme that'll break this bond, but galactose is different than glucose, and they can't break that bond. And if you are lactose intolerant and you can't digest it, it goes all the way through your system, and it ends up, the lactose sugar ends up in your large intestine, your colon, where there's bacteria that can break it down. And the bacteria will break it down and produce all this gas that will swell up your intestines, and it hurts real bad. And you got to fart it out, you know? And it gives you really bad gas. So people who are lactose intolerant don't want to eat it. Some people they're so bad it can kill them. You can die from gas. It'll also give you diarrhea. It just makes you feel bad.
You take anything?
Yes. All you got to do is drop a lactate tablet into the milk. Or, a lactase tablet. That's an enzyme, that's the enzyme you're missing that can break this down. So they actually sell milk like that. It's called Lactaid. It's in the milk aisle. You can see it in the grocery store if you ever look. And it's more expensive, but they've put the tablet in there and it breaks down all the lactose. So you can just drink it straight. It doesn't taste any different.
That's crazy.
Isn't that great? And so I actually like Lactaid milk, although I'm not lactose intolerant. it doesn't spoil for like 2 or 3 months.
Really?
Yeah.
That's what.
Well, I don't know. I guess the bacteria aren't able to use that energy for breaking down the lactose, so they don't grow as fast in the milk. So I don't drink milk that often, so I'll buy a big thing of lactate and not have to worry about it. Isn't that cool?
Crazy.
There you go. You're learning stuff. You're learning stuff in school, even though it's so hot. Hey, that bond that has an O in the middle that goes between molecules is called a glycosidic bond. Can you say glycosidic?
Glycosidic.
That's a bond with an oxygen in the middle. Oh, here are the disaccharides that I mentioned. There's lactose. There's maltose. And there's sucrose. Now, finally, let's talk about polysaccharides. You got monosaccharides, you got disaccharides. Here, I'll do it on this board. You can just hook a bunch of these together, one after another, and make polysaccharides. Poly means many sugars, hooked in a chain. Now, polysaccharides, there's a bunch of different kinds. There's really 4 kinds that we're concerned about in this class. There's starch. Have you heard of starch? There's cellulose. Cellulose is the most common molecule on this planet, except for water. Yes, so cellulose makes up the cell walls of plants. You're writing on cellulose if you have paper out. And that's amazing to me. I mean, think about paper, you know?
There's a lot of paper.
Paper is sugar molecules hooked together in a line.
What I'm hearing is I can eat this.
And you could eat it if you could digest it.
Oh, I can't digest that?
But you can't digest cellulose because cellulose molecules, the sugar molecules are like this, and then there's another layer underneath them, and then they're bonded together by these bonds, and you don't have any enzymes that can break that apart.
Darn.
There are bacteria and things that do. And these bacteria live in the guts of herbivores. And they live there's a pouch all herbivores have in their digestive system that have these bacteria that can break that down. And so they'll just eat grass, and the grass will go in the pouch, like a cow, you know, just eats grass. The grass goes in the pouch. The bacteria break it down into sugars, and then it goes back up in the throats, and then they swallow it. Have you ever heard of a cow chewing its cud? And you see it's chewing the stuff that came back up for re-swallowing.
So it's like throwing out.
So it's not really throw up though, because it's useful. They're not getting rid of waste. They're enjoying that. It tastes good to them because it's sugars. That's their dessert. Now we used to have a pouch like that. You go back in the evolutionary history of humans, because humans are primates, and primates used to live up in the trees and eat leaves like monkeys do. Have you ever seen a monkey has this big belly?
Yes.
That's the pouch that'll break down leaves. Now, when apes evolved, they went to a diet of fruits and meat, and which is richer in nutrition, and they lost the pouch, and then we evolved from apes, so that's why we don't have it. You know what's left of the pouch?
The appendix.
Your appendix.
Let's go, baby.
That's what's left of the pouch.
Why are there some plants that we can eat and some that
Well, any plant that you're eating, you're still not digesting the cellulose. Like if you eat lettuce, that's mostly cellulose. Just goes right through. It's good for you because it has roughage, which kind of scratches the walls of your intestine and keeps them clean. People who don't eat many leaves have dirty intestines. Tell them that. They say, "Oh, I don't eat vegetables." Go, "Ooh, you have dirty intestines." But it really doesn't give you any calories.
Okay.
But there's lots of plants that you can eat that give you a lot of calories. Rice, potatoes. You're eating the food molecules that are stored in the seeds. And those are starch molecules, which look not like cellulose. They're long chains like this that you can break down and get the sugars out of. So if you eat a potato, you're eating big, long starch molecules. Those are easy to break down. You get lots of calories. And they taste better. Make sense?
Yes, sir.
Are y'all learning?
Yeah, so much.
Oh, so there's two other ones. There's cellulose. There's starch, there's cellulose, there's glycogen. Glycogen also looks kind of like this. It's how sugar is stored in your liver. Now, after you eat, if you eat, let's say you're just spooning out sugar like I do when I have my Rice Krispies. Well, I'm not going to use all that sugar right away. So those molecules get stored in my liver as long-chain polysaccharides called glycogen. And then later in the day, my liver can release that sugar as I need it. So your liver is constantly just doling out sugar, and it pulls it all in after you eat and stores it like that. This is good for storage. And then the last one that you'll hear about in biology is chitin, also known as chitin. You can say it either way. I like to say chitin, I don't know why. But anyway, chitin is a tough molecule that makes up the cell walls of fungi. A fungus has tough cell walls too, but it's a different structure than plant cell walls. And it's called chitin. Okay? So, let's move on to lipids just real quick. And then we'll do some work on the boards here. So all this stuff that I have down here. All this stuff that I have here, these magnets represent fats. These are the building blocks of fats. So, what are they? This is called glycerol. It's 3 carbons with some OH groups sticking off of them, and hydrogens filling up the rest of the bonds. So it's C3H8O3. And that's kind of the starting block if you're going to build a fat. It's called glycerol. And there it is up at the top. Can you say glycerol?
Glycerol.
All at the same time?
Glycerol.
Sweet. I love that. It's something I like to do. Now these things here are the other part. They're called fatty acid chains. Fatty acid chains are long strings of carbon atoms, just one after another in a long line, with hydrogens attached. And at the other end is a carboxyl group. I don't know if you remember what a carboxyl group is, but it's COOH. And the carboxyl group and the fatty acid, this whole thing is called a fatty acid chain. It will connect to the glycerol and form a bond there. And just like before, when this connects, it's a dehydration synthesis reaction. So an OH comes off one and an H comes off the other, and you're left with a glycosidic bond. And now we have we've put a fatty acid chain on there. And you can actually put 3 fatty acid chains on there. Click. And click. And now you have a fat. We call this type of fat a triglyceride. Tri meaning 3 fatty acid chains. A triglyceride. There it says right there. Triacylglycerol. Triacylglycerol, I guess is how it's pronounced. So, that's a fat. Now, sometimes the fatty acid chains have a double bond in the structure. They're a little bit bent. Anytime you put a double bond in the structure, it makes the chain bend. Oh my gosh, I just recognized a mistake in my magnets. There shouldn't be 2 hydrogens there. This should be gone. Huh. That will have to be fixed. So we call that a fatty acid chain that has a bend in it. We call that an unsaturated fatty acid chain. Have you ever heard that before? Saturated if it's straight, it's unsaturated if it's bent. Okay? So that's the building blocks of a fat. I'm going to finish talking about lipids tomorrow. Here's what I want you to do. Go back up to your board with your group, and I'm going to call out some molecules, and I want you to identify them. And I want you to go one person at a time. So 2 people step back, and 1 person take the reins.
Mr. Willis?
You got it, Ken?
You can turn that off.
Okay.